SmokeGuard's AIA Continuing Education series. Today's AIA course is titled Passive Fire and Smoke Protection for Senior Living Facilities. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. SmokeGuard is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS Group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. SmokeGuard offers flexible, visually appealing fire and smoke protection systems designed to cover everything from small openings to large atrium spaces. SmokeGuard offers a full line of elevator smoke containment systems, including vertical, horizontal, and perimeter fire and smoke curtains, as well as shutter and static curtain solutions. SmokeGuard is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your member number, we will report your course completion to AIA for credit. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by SmokeGuard. Any reproduction, distribution, display, or use is prohibited without written permission. In this course, we'll explore how the design of senior living facilities must account for the unique needs of residents, especially in terms of life safety and comfort. We'll look at how smoke compartments and egress strategies are tailored for these environments, guided by codes like the IBC and NFPA 101. Finally, we'll examine the fire and smoke protection solutions available to architects, comparing their advantages and trade-offs within this specialized setting. This presentation was pre-recorded by David Bauer. David is the Architectural Director for SmokeGuard. With that, let's turn it over to David.
First question is, since we're talking about all of this in the context of passive systems, and in particular, in this case, what are particularly valuable passive systems, this is an example of a hospital, not senior living, but it does share some qualities with one of the subsets of senior living. But in this project that I did, I don't know, a decade and a half ago or so, we're doing a cafeteria and it opened to the corridor. The corridor in the hospital, if you've ever done hospital work, you know that it's smoke rated and not fire rated. And so I had to have an opening in that wall that is smoke rated and not fire rated that complied with the requirements for that wall type, that being a smoke partition as defined in the code. So I put in, my choice at that time was a very common choice, probably, I don't want to say the only product available, but it was an overhead coiling steel system. It was the right choice for this application. And I think out of any 100 architects, 99 would have picked the same thing. It was difficult to put in there because this particular product had, I believe it was a 20 or 22-inch housing size. It had to go up in a hospital ceiling, which is not an easy thing to do. But we accepted it as just being par for the course because it was the normal thing we would do. And so we did that, and that was, we accomplished our goal. We had a smoke-rated system. That was probably the right choice for that time and era. Today, however, we wouldn't use that coiling steel system. Today, we would use a fabric system. And if you think about the reasoning behind that, twofold really, I'll give you the lesser of the two. The lesser reason of the two is weight. You don't have a particularly large system here, but the fabric systems are going to run somewhere in the neighborhood of 20% of the weight of the steel systems. However, the housing size is the big driving factor in this case. That 22-inch housing that I had back then on this project would today be about a 6-inch housing. Big advantage, particularly when you're working in cramped quarters and particularly when you're working renovations. So that was the story behind the story on that. Before we get too deep into senior living and the things we have to do, can't do, must do, should do, let's talk about wall types briefly. We found that there are some nuances in the different wall types that are probably not understood to the degree that they should be. Fire walls, fire barriers are fire-rated walls. We use them all the time. That's why they start with fire and not smoke. However, the trick here is that smoke barriers down below are fire-rated also. So the first four of these are fire rated. The last three of these are smoke rated, and then there's overlap in there. Now, what we're going to find as we go through senior living facilities is that there is a pretty extensive use of fire partitions and smoke barriers, depending on what type, what condition of senior living we're looking at. But it's important to understand that these are the different wall types and what they do. You can build a 1 hour fire partition exactly with the exact same UL assembly type as you would for a 1 hour smoke barrier or a 1 hour fire barrier. The assembly type would not change. It'd be exactly the same construction. The difference comes in with the openings. With fire barriers and firewalls, for that matter, you're limited to no greater than 25% of the openings, of the wall being openings. When you get down to fire partitions and smoke barriers, for the most part, with exceptions, but for the most part, you're going to have 20-minute opening protectives, 20-minute fire-rated opening protectives. But you will also be required to have an S label on those doors, unlike that in fire barriers. When you get smoke partitions, all you need is a smoke-rated door. Now think about it. You're providing an opening protective that is in line with exactly what the requirement is for the wall, just typically a lesser rating. So for senior living, this falls into institutional group I1. Note that in California, it's a different occupancy type. It's they group it into group R2.1. So there's a different occupancy type there. But for this one, the normal IBC, it's group I1, and it falls into two different subsets. Condition 1, Condition 2. So Condition 1, to summarize this, you can read that as well as I can, but to summarize this, Condition 1 is analogous to a residential occupancy. Just senior living, not necessarily even assisted living or an elevated form of that. Condition 2 is very much analogous to a hospital. So its construction and its fire and life safety requirements are similar to a hospital. That would be something more like a memory care center. Or some function such as that. So these are very different. And once you make a jump from one to the other, it's like making the jump from residential to hospital design parameters. So we'll get very specific about what those are, but bear that in mind. And that's basically the main breakpoint. This is one of the most important and underappreciated, or I don't want to say misunderstood, but underapplied concepts in the entire building code. The phraseology that we used to use is that if you have two requirements placed on one building element, two different code requirements, and they're similar to one another, that the more restrictive of the two would govern, and that's incorrect language. That is not the case because that would imply a decision. We have to decide which one of those two is more restrictive. That is not the case. It's actually additive. If you have that section of wall that's within that black dashed box, that section of wall has to be both serve the needs of both the 2 hour fire rated wall for that shaft or whatever the space is in red, also has to serve the requirements of the blue walls that define that corridor, presuming that's a corridor. That section of wall that we're looking at has to do both of those. So whereas the red wall that might be a fire barrier for that shaft only has to be a 2 hour fire rated wall with no smoke rating, and then the corridor has to be smoke rated but has no requirement for a fire rating, that section within that box has to be 2 hour fire rated and smoke rated. So in terms of construction of the wall, it's very similar construction. 2 hours a little different than 1 hour, but so you'd have two layers of type 5 or 5/8 type X chipboard on the interior of that wall, for example, on the corridor side. But any penetration through that would also have to be smoke rated, not for the purposes of the fire barrier, but for the purposes of the smoke partition. So if that one section of wall is defined as two different walls, it has to accommodate the needs, uses, restrictions, and requirements of both of those walls, not the more restrictive of the two. I'm going to cut to the chase a little bit and give a little sneak preview here. In assisted living facilities, you are very nearly always going to have a fire and smoke rated wall type in the form of a fire partition. So the concept that we just talked about would come into play in this. With that combination wall that is defining both the corridor and that shaft. So if that shaft is for an elevator, the penetration in that wall is not only a penetration in a fire barrier, it's a penetration also in a fire partition. It has to satisfy the needs of both of those. If that wall did not need to be smoke and fire rated for the corridor, then all we have is fire barrier. All you need is the 90-minute opening protector for the elevator, and you're done. However, in this case, we additionally have to provide a 20-minute fire rating for the corridor, which we've already accommodated with the 90-minute fire rated door. But we also have to accommodate a smoke rated opening protective as well, which is not accommodated by the fire rated elevator door. If you go to section 1020.2, this used to be 1020.1 in earlier versions of the code, but there have been little tweaks and adjustments of this over the years through generations of the code, but by and large, it's remained basically the same. But if you look at the occupancy type we're talking about, that being an I1 occupancy group in yellow down there, and you look across there, you can't construct it with new construction without it being sprinklered. And if it's sprinklered, it has to be 1 hour fire rated corridors. Okay, so what do we have to do there? What does that mean? What kind of a fire rated corridor? What kind of we know that we need to have a 1 hour fire resistance rating, but what does that mean? Well, the charging language tells you that that has to be constructed as a fire partition. So now that we know it's a fire partition, we have a section that tells us what we have to do with fire partitions and the nature of the ratings for that. So in this case, that corridor, regardless of what that space is, it doesn't matter that that's an elevator shaft. It could be anything you want. But since it is an elevator shaft, we already have the 90-minute doors, as we looked at a moment ago. This is additive because of the requirement for multiple use fire assemblies. And since that corridor is required to be constructed as fire partitions, openings in the fire partitions also have to be smoke rated. So this is more of the detailed look under the hood of what we just learned in the previous slide. So we see this sign, we put this sign in front of elevators. Why do we do that? Well, we don't want somebody to be using an elevator if the building's in alarm mode. But just how exactly does that work? Well, the details of how elevators function in a fire condition are detailed in the elevator code, safety code for elevators and escalators. This is referred to in the International Building Code. So as architects, we are responsible for this. It's a referred document, just like any of the, I mean, sometimes when we read these things, it looks like 100 million referred documents in there. There are probably more than 1,000 of them, but this is one of them. So we do have to adhere to this. And from this document, it's important that we understand how elevators work. So elevators basically work in one of 3 modes. There's normal operating mode, which is essentially like an automatic car. It's just you push a button, it goes there. It's easy. But when the building goes into alarm, what happens? Does the status of the elevator change? No, it does not. The status of the elevator only changes when smoke contacts the smoke detector immediately outside the elevator. Now, if you scour the building code for that information, you won't find it. It's in the elevator code. But it is important to understand how the elevators transition in that building from normal operating mode to phase 1 emergency recall. And it is only because of the smoke detectors associated directly with the elevator. Those in front of the elevator door, those in the top of the shaft, and those in a machine room if you have a machine room. What else do we need to know in the elevator code? Well, when that happens, that elevator goes in that phase 1 emergency recall mode. The elevator goes to the level of exit discharge and the doors lock open and the elevator is now immobilized. You can't use it anymore. So if you walk into that elevator on the ground floor and push the 3rd floor button, it's going to say, nope, not going to do it. We're not doing anything right now until the fire department shows up. So that elevator has gone out of commission, but only because of smoke sensed in front of that elevator. If you have a broad floor plan, like a senior living, many times, oftentimes, most times actually, you can have a fire down at the far end of the building's in general alarm, and when you walk into that elevator distant from that fire, that elevator is in normal operating mode, and it will not transition into phase 1 emergency recall until smoke reaches that point. So it's important to understand the function of the elevator. Phase 2 emergency recall is simply when the fire department shows up, turn their key, and now it's similar to what we normally experience in normal operating mode, except that it's in manual mode for use by the firefighters. And ideally, everybody is out of the building by that point in time. So that sign in front of the elevator is actually doing something because you hypothetically can use the elevator. So section 3006.2 in chapter 30 for elevators and conveying systems will tell you one of the other locations that affects the function of the elevators. So we're going to talk about various vertical openings. We're starting with elevator shafts here to begin with. So this building says that, and again, we're narrowing this down to group I1 occupancies. So just because we're talking about I1 here, don't think that there are not other requirements for other occupancy types. So, but we are dealing specifically with I1 occupancies here. So, and also you can have an accessory use building where you have another occupancy type within the greater occupancy. And that can be subject to different requirements as well. Generally, they'll be more lenient than this, but they might still be there. So be aware of any accessory uses that you have in this building, but we are predominantly focusing on I1 occupancies. So if you have an elevator, and if you have an I1 condition 2 occupancy, and remember we discussed condition 2, such as memory care, I'll reference memory care a lot here, and it is greater than 3 stories, you have to have smoke protection at the elevator. Now, remember, we already talked about if an elevator opens into a corridor, for the purpose of the corridor, you already have to have smoke protection at the elevator. This is an additional place you have smoke protection at the elevator. So in many cases, you may have two requirements. Now, there are exceptions to this. So for example, the first one we see a lot. Well, we see a lot of them. You won't see the second one very often in senior living facilities, but the first one you'll see a lot. So if you have the requirement for a 4-story senior living facility, and it's a group I1 condition 2 occupancy, you know now that you have to provide smoke protection, but you can omit that at the level of exit discharge. So that's typically going to be the ground floor, typically going to be the first floor. So you don't have to provide any smoke protection there. Now, what happens on the ground floor if the elevator opens into a corridor, which is otherwise required to be fire and smoke rated? Can you then omit the protection at the level of exit discharge? No, because this exception applies to this requirement. That's not a universal exception that you never, regardless of any requirement of the code, ever have to provide that protection. That addresses this requirement specifically. So if you have a separate requirement, you have to accommodate that requirement. Again, we go back to multiple use fire assemblies. So what are the solutions? So in 306.2, it tells you when you have to do it. And in 306.3, it tells you what you can do. This gives you your solutions here. There was one change in the 2024 IBC, and we'll mention that as we get to it. But option 2, we're skipping right over option 1. Option 1 is for an unsprinklered building. And since we can't do that, at least in new construction and senior living facilities, we're not even going to address it here. So in a sprinklered facility, option 2 is the first one you come to, and you can provide a smoke rated corridor. Elevator lobby. So that's pretty easy to do in this case, because remember, if we have a corridor and we have a separate elevator lobby, the separation between the two for the purposes of the corridor is already smoke rated and 20-minute fire rated. In addition to that, then if you provide an elevator lobby, you don't actually have to do much of anything because you have a smoke rated lobby that is defined as being bound by smoke partitions. Opening in a smoke partition is shown in the code in chapter 716 and section 716 as being a UL 1784 rated smoke rated door, which we already have. So there's very little to do in this case that we haven't already had to accommodate to begin with. Now let's look back a little bit. We mentioned UL 1784 a couple times, and that may be somewhat enigmatic to you. The code defines UL 1784 as a standard that has to apply to any kind of a smoke rated door. It is the testing standard by which those doors are tested. It is not the level of leakage that is permissible by the code. That information is in the code. So if you take the leakage allowance and the UL 1784 standard that is required and you marry them together, that gives you an S label. So when you put S label in your door schedule, that's probably the best, most complete way to describe the requirement for that door. And that will give you both the UL 1784 standard testing and the limits and the leakage limits that are already established in the code. So that's one kind of elevator lobby we looked at. This is another type of elevator lobby. You may egress through an elevator lobby. That's both good and bad. That is maybe a little bit more convenient, but consider this scenario here. Note the door swings in this case. That's a clue as to what we're going to see in a moment. Now, what do we have here? Now we're looking at, this is not a senior living facility. This is in fact a hotel, but this could very easily be a senior living facility as well. And the requirements in this case would be the same. So we have a lobby here. Now think about your direction of travel down to that exit side in the distance. Do these doors accommodate that direction of egress travel? Well, the near ones do. They open in the direction of egress travel. We've got panic hardware. We have another means of egress behind us that we intuitively know is there. But as we go through that second pair of doors to exit the elevator lobby on our egress path, even though we may egress through an elevator lobby, we have to egress through doors that open in the direction of egress travel. And those doors do not do that. Well, okay, let's just fix that. Let's flip the door swings. Well, now we have the problem going the other way. The reality of the situation is, even though an elevator lobby is a very simple solution, there's some details that you can get hung up on if you're not paying attention to them. So the only solution in this case, since we have linear egress through this elevator lobby in both directions, is to have double egress doors. Now, is that going to cause us a problem? Potentially. Because if we look at the far side of the lobby, there's a little mini corridor or something that goes off to the right. What does that go to? Well, we don't know from the information that's presented here. But that door swing, if that's swinging outward, could obstruct egress from that direction. We have to look at what that is and whether that's permissible or not. The greater point is look for details. you can't obstruct your egress path, and you have to provide the proper rating. Now, speaking of the proper rating, what is the proper rating on these doors? Now, remember, an elevator lobby in a sprinklered building in a residential occupancy, whether it's I1 or I1 condition 1 or 2, has to provide smoke protection from the elevators or to the elevators. That is in the form of a elevator lobby constructed with smoke partitions. Openings and smoke partitions are required to be smoke rated. Pretty straightforward, and are not required to be fire rated. So what does that label say? Let's look at it a little more closely. We got a 1 hour fire rating, and we do not have a smoke rating. So we appreciate the extra effort that they've given us in giving us a 1 hour fire rated door that we do not need. That's always good. Go over and above is fine. However, we do need a smoke rated door. We haven't been given that. So this is another fail. So we have two separate independent fails on this very, very simple elevator lobby. Lesson learned, pay attention to the details. They're important. Several years ago, I came across a door that wasn't labeled. It was at my father's senior living facility. And as I went to walk in the door, there was no label on the door. And that annoyed me to no end, because that's the kind of nerdy stuff that I look at. So I was talking to a friend of mine who's a fire protection engineer, and I told him this, and he said, that label could be on top of a door. And I said, I scratched my head. And this is after having been licensed for over 30 years. I said, really? Probably something I should have known. I didn't know that. And it's a little mysterious. A lot of us don't know that. So I went back to my dad's senior living facility. This is not it. This was literally the next door I came to after that fire protection engineer told me that. The next one I came to without a label, I checked, and sure enough, this was on top. Back to my dad's senior living facility, this was his door. So as I felt across the top of the door, I felt a label, and I thought, this is great. He has a labeled door, and he's supposed to have a labeled door. It needs to have a labeled door. And then, of course, I held my camera up there and took this picture and realized, oh, I guess it's not labeled after all, because a label that's painted over invalidates the listing, because no fire marshal can look at this and know what that means. So this is also the only door on planet Earth that actually, in which the painter has actually painted the top. It's the only one I've ever seen anyway. So additional doors. So we are required, again, to provide smoke protection in certain facilities, including all senior livings where the elevator opens into a corridor, and anything over 3 stories if it's condition 2. So one of our available solutions are additional doors. Now, this is the section that has been split into portions in 2024. So I'm going to talk about one type of additional door, but when we get to another solution, that in 2021 and earlier was included in this subsection. So what are we left talking about with additional doors? Visualize that for a second, and if this comes to mind, yes, this could be your answer. Is this code compliant? Well, in the big picture, it sort of is. We can put additional doors there. Why are we doing this? We're basically putting in a lobby with no space. So we're providing the same protection that smoke-rated lobby would provide, but without incorporating any space. We have doors right in front of the elevator. Their only job is to provide an S label for that elevator. But in being there in front of the elevator, they have to accommodate a couple things. One is they have to accommodate egress. You have to be able to get through it in some way. Well, it's a side hinge door. That's pretty straightforward. So we are there. Oh, wait, there's one more thing in the elevator code that we haven't discussed, or not in the elevator code, excuse me, in the building code that we have not yet discussed. And that's the requirement for the S label, but the code very specifically says also tested without an artificial bottom seal. Now, if that enigmatic language strikes you as a little bit strange, because if you consider the converse to that requirement, does that mean that we can test a door for smoke leakage with an artificial bottom seal? And if so, what does that mean? Does that mean that we take duct tape and tape the bottom of the door before we test it? Well, that's exactly what it means. And that's exactly what they do. You are permitted to duct tape the bottom of a door before you test it at a testing lab like Intertech or UL or somebody like that. Why is that? Well, a couple reasons. Generally, smoke comes from above because it's hot, it's up in the ceiling, it works its way down as it fills the room. Only at the very end of that period of time will it leak underneath the undercut. But also, we undercut doors. We do it for HVAC purposes. We have flow return air through there. We have clearances for maybe, in general indoors. We have threshold requirements. We have ADA issues. We have clearances for maybe a heavier carpet or something like that, but we have undercuts on doors all the time that are greater than 0. So we'll always have leakage down there, and they permit you to tape that undercut. However, that undercut taping or that additional bottom seal is not permitted in front of elevators. So this is really important because smoke is coming from below. It can immediately go through that undercut if that's not tested without an artificial bottom seal. So as ridiculous as that sounds, that's very, very important in elevators. Let's go to something else too. When we review projects, we specify these doors. Maybe we have provided an S label, which, by the way, I'm not aware that you can get in a side hinge slab door. You can get that in some integrated hardware doors. You can get that in some other type devices, but you have to look for that. But what else is there waiting for us? That's actually in the building code. That's easy to find. Well, it's not easy to find, but it is findable. But there are requirements that are also in the elevator code that we need to be aware of. Remember, the elevator code is referred to in the International Building Code. We are responsible for its content. So if you go to the elevator code, is there anything there that pertains to these doors that we need to be aware of? Well, they say things like has to comply with other building codes. Okay, great. We're already doing that. It also says in the elevator code that you have to provide visibility with the elevator doors no greater than 1/4 open. Well, what does that mean? Well, it doesn't say anything more detailed than that. You just have to have visibility. So this clearly has none. So that would imply to me, or my inference might be that maybe put in a half light, but maybe it's a 10 by 10. Either of those is not wrong. I would probably lean towards a half light just to provide more visibility rather than less, but it has to be visible such that when the door is 1/4 open. The other advantage to a half light is that if they change the elevator, if the elevator spec changes in mid-construction, and for whatever reason, it's right-hand acting instead of left-hand acting, you'd had that backwards. You don't have to coordinate that with a half light. So what you really want to make this as easy on yourself as possible is as much visibility through that door as possible. This one clearly provides 0. And I will tell you right now, this is not tested without an artificial bottom seal. So this is a fail on 2 levels as well. There's another example of an additional door. Well, this one works great, doesn't it? Look, it looks like it closes over the entire thing. It doesn't have the visibility, so we've missed on the elevator code, but it has a closer. It'll close automatically on alarm. It would function much better if the closer was actually connected, but this is something that we do see, and if any of you have been in the field, you know, you see these kind of things all the time. This is a project in which another method was employed for solving the elevator smoke mitigation problem. So in this case, this is a residential facility, but just to illustrate a point, their choice of elevator smoke protection was to use option number 4 of elevator shaft pressurization. This is not wrong. This is fine, as long as it works. In this 12-story building, they put it in there and they could not make it work, and they tested over and over and over again, and they couldn't make the system work. What they had to do was after about 90 days, they drop back and punt, and then they ended up with what would have been a much more cost-effective solution. Now, this is a new section. This was added in the 2024 IBC. However, everything in this section had heretofore been included in option number 3 for additional doors. So this is a subset that was pulled out. And the reason it was pulled out as a separate section is because it's so prevalent today. It used to be, when it was first conceived, an odd, strange, different kind of solution that you had to really think through. Does it work? Is that really an additional door? Well, now it's been given its own section. So smoke protective curtain assemblies are here to stay, and they're very prevalent these days in the marketplace. Well, why are they so prevalent? Well, they're better than additional doors. And we saw some of the problems with additional doors a moment ago. But these basically do the same job as an additional door. They provide the protection that a lobby would, but without having a lobby. You don't have to sacrifice, 200 square feet as a lobby. So what do you have to do? Exactly the same criteria as an additional door. We're providing the S label. So what do these things look like? Well, there are 2 types. This is probably the more historically prevalent type. Well, certainly the more historically prevalent type. These have been in the marketplace for in excess of 30 years. And they really haven't changed much. What does it have to do? It has to provide the S label that the elevator door does not. It does that. It has to do so without having been tested without an artificial bottom seal. It does that as well. So these are all tested without an artificial bottom seal. Make sure to look for that. The manufacturer should give you the testing. If they don't, then you might want to look somewhere else. but it has to be tested without artificial bottom seal. The elevator code says it has to have visibility through it. Now, this is a fairly recent development in the elevator code, about a decade ago. Every state, with the exception of California today, requires that. But this type system had always had that visibility through it, even though it wasn't required. So when the elevator code did change to incorporate the requirement for visibility in the 2010 version, this already had it. Other manufacturers had to scramble just a little bit to incorporate that in some way. So this was based entirely on visibility being inherent to that system. So you have to have egress through the system. In this case, you can do that with a push button or by just walking through the system. And ideally, they should only deploy when triggered by that immediate smoke detector outside that elevator. And the best way to do that is directly from that smoke detector. In some cases, there may not be the contacts available for that, in which case then it needs to be triggered by the fire control panel. If so, it is strongly recommended that it be zoned to that floor and that smoke detector location specifically, because you don't necessarily want these things going off all over the place during a very limited smoke event. This is an example of those installed. You can see evidence of these systems, but you do have to look for it. And if you look right above the elevator doors, you can see a small door in the ceiling that's slightly different color from the ceiling. That's the housing from which these systems deploy. Again, tried and true. It's been around for 30 plus years. I mentioned there's another type. Now, this is a terrible picture, but the advantage of this picture is that you see the system. In most cases, nearly every other case, these systems will be buried in additional construction in some way. So, but this one you can see, so we can actually see what we're looking at. There's a housing up above. It just works in the inverse manner to the magnetic systems, in that instead of it adhering to the elevator jamb or a rail by the manufacturer, this will go down through a slotted channel, a side guide through which the system deploys. So it inherently moves up and down. The other one moves up and down too, but you can egress through it. This one you can't egress through unless you have one of two ways to do it, and you have to have one of these two ways. Either you have to have some kind of an articulated device through which you might egress, or you can have a means by which you can raise this system up, opening it so that you can egress through it. Now that egress, that raising of that has to be designed in such a way that you're not required to use more than 15 pounds of effort to do so. So that has to be in place. So these systems used to not be fully successful in earlier bygone eras. In the last probably 5 years, we see marked improvement in these, and there are some very successful systems. Again, same requirements apply. Tested without an artificial bottom seal, have to have visibility. The elevator code does not specify where visibility is. So we've seen all kinds of different systems where you have a smaller view window at about eye level. We've seen systems where you have a smaller view window around knee level. But your best bet for success, seeing as how you don't know the elevator inspector and you don't know what his interpretation of that code requirement is probably go with as much visibility as you possibly can. Now, in some buildings, and this applies also to senior living, you're required to have fire service access elevator lobbies. What is that? In a building where you have an occupied floor over 120 feet above the lowest level of fire department vehicle access, you have to have fire service access elevator lobbies, and they're required to comply with all of these requirements. The one thing that you need to pay attention to is the fourth point, where it says you have to have a 45-minute UL10C and UL1784 system tested without an artificial bottom seal. This, to my knowledge, is the only location not immediately in front of the elevator where you have the requirement for testing without an artificial bottom seal. So let's look at the details of fire service access elevator lobby. Probably not super common in senior living facilities, because you generally, not exclusively, but generally have low-rise buildings, 2-3 stories. But we do have high-rise senior living facilities as well too. So we do have to accommodate these. So it bears discussing. There's that 45-minute smoke rated door. Again, 45-minute. Your requirement for enclosure of the elevator lobby is a smoke barrier. If you recall back earlier, and we touched on this very briefly during our discussion of walls, an opening of a smoke barrier is generally speaking going to be a 20-minute smoke rated system, and not required to be tested with that artificial bottom seal. When used as the entry into a fire service access elevator lobby, that is raised from 20 minutes to 45 minutes. And that smoke rating now has to be a smoke rating tested without an artificial bottom seal. Be very cautious of this. I would venture to guess that of the projects that I look at least 75% of those show non-compliant doors. I would actually say probably more than that, probably more like 80, 85%. So what are they doing? Most of the time they're using slab doors, which are not tested without an artificial bottom seal. So that means that smoke will be pouring into this elevated lobby while firefighters are using it. Not a great solution. Let's move on to a different type of vertical opening. Let's talk about atriums. Now, it's important to note that in the 2021 IBC, the definition of an atrium changed. It doesn't directly affect the end solution that you have. However, it does affect the means by which you get to that solution. So it is important to understand this. In previous versions in 2018 or earlier, we might have a 2-story vertical opening in a senior living facility that we call an atrium, and you could do that. And in that atrium, there was an exception where you did not have to provide smoke control. So it was easy. You had an atrium, you had no separation requirements, which we will investigate in a moment, and you had no smoke control requirements. So it was a very easy thing to do. In the 2021, it changed. So now in a senior living facility, if you have a 2-story vertical opening, it can no longer be called an atrium. Well, it doesn't present as big a problem as you might think because there's still an available definition for that space, obviously. It's just not able to be called an atrium. And it does take us back to the same solution. So the first place you look, if you have an atrium, let's look at section 404.6. There are 2 subsections in 404 that are of primary concern, 404.6 and 404.5, and we'll discuss those in sequence. We'll start with 404.6, where it defines the requirement for enclosure. And the very first thing you see is this. So if I have to have an atrium, regardless of anything else, and I have to enclose it with 1-hour fire barriers, 2 things happen. One is I have a very definitive enclosure and my windows are limited. So the minimal visual access I have into that atrium is truncated significantly. So you are down to maximum visibility in and out of that atrium to only 25% of each wall. That's pretty restrictive. Make sure that when you're going through the code, you read the exceptions because there's some particularly valuable exceptions right here. Exception 1 allows you to substitute for that fire barrier. Well, that's significant. And it specifically, prescriptively allows you to substitute sprinkler protected glass. And it says forming a smoke partition in literally those words. Well, okay, this is tremendously better if for no reason other than an opening in a smoke partition can potentially be 99% of that wall, even if you're substituting a different type of smoke partition. But it does specifically permit sprinkler protected glass. So you can do that. So now you have visibility. It's interrupted by an actual experience of the atrium. So you're in a different space because there is a barrier between you, but that can be all glass. Sprinkler protected. The sprinklers only have to be on the walking side of that glass as well. But as you can substitute via alternative means and methods, you can substitute other solutions. This is a very, very easy thing to do in this case, because you can substitute something as a performance-based solution, although not the prescriptive solution that's discussed specifically in the code, the performance would be the same. So if you provide a wall with a very large opening in it, that's definable as a smoke partition with the applicable walls, potentially an overhead coiling fabric curtain that is tested to the requirement in a smoke partition, that being smoke rated, then you've complied with everything that is required by the prescriptive solution. It is an alternative method, and it is about the easiest alternative method that there is. So okay, we've done that. Say we use sprinkler protected glass here, or smoke rated curtains here. Well, we still have them at 4 floors. Keep reading the exceptions. Exception 5 lets you leave 3 stories unenclosed. Well, okay. So what looked pretty egregious in the beginning as complete enclosure with fire barriers now is only minimal enclosure with smoke partitions. A much, much easier solution, but you have to read the exceptions. So this is the entirety of our requirement for enclosure in a generic building. So we'll get into some of the nuances of some other things in a moment that apply to, in particular, condition 2 of I-1 occupancies. But let's talk about smoke control first. Section 404.5 says that you have to have a smoke control system. okay, in any atrium. Now remember, a two-story vertical opening is no longer an atrium. So this applies to all atriums. If it's definable as an atrium, it is required to have a smoke control system. So what do? We already have our enclosure accommodated here. Now we've added in a smoke control system. Very generically, this is a mechanical solution, but it doesn't have to be a mechanical solution. There is no wording, no language whatsoever in the code that says that the solution for smoke control has to be mechanical. It can be passive. So mechanical is an active system. You got a big fan unit pulling the smoke out. In order to pull a certain volume of smoke out, you need to introduce fresh air as makeup air, as we do in the bottom. So very generically, very simply put, this would be a typical diagrammatic smoke control system that would apply. The problem with these is they're very, very expensive. So one of the other driving requirements is you have to keep smoke at least 6 feet above any surface required for egress. So, okay, so we have done that. We just upsize our mechanical system so that we've pulled the smoke out faster than it can get to that point within the specified time allowed. Well, what would happen if we added what is not required, but might be helpful in this case? Let's take and we'll put another, on the third floor, we'll enclose that with smoke rated fire or curtains, not fire rated, just smoke rated. They're only there for smoke control. They're not there for fire rating. There's no requirement for enclosure. We're only putting it in there for smoke control. So why could you not do this? Well, you absolutely can do this, but what does it gain us? Why would we do it? Well, we do it because if you spend $1,000 on fabric curtains, you're going to save probably in the neighborhood of $3,000 on your mechanical system. It's a significant savings because the mechanical smoke evacuation system is so expensive. So if we do that once, can we do that twice? Sure we can. And that makes it that much less. So now we might be hypothetically spent $2,000 on smoke rated curtains, and we saved $6,000 on mechanical smoke evacuation system. Those are ratios, those are not real numbers, so the numbers will be much, much bigger and much more obvious as a savings to your budget. But that is a technique that is used all the time. Now, what do we have here? So, okay, let's talk about another overlying requirement that only applies to condition 2 of I1 occupancies, does not apply to condition 1. Remember earlier we talked about condition 1 being analogous, not the same, but analogous to residential occupancies, and condition 2 is more analogous to hospital occupancies. So in condition 2 occupancies, such as memory care centers and some other types of facilities, we're required to have smoke compartments. And that's principally because the occupants or the patients within really don't have the wherewithal or the capability to self-evacuate. And in this case, you really don't want them self-evacuating. So we have to provide smoke compartments if in this example, it was a condition 2 I1 occupancy. So we can't have airflow from one occupant or from one smoke compartment to another. So we have to separate them. How do we separate smoke compartments? Well, if you go to 420.6, section 420.6 noted above, then you'll find that the requirement for separation between smoke compartments is a smoke barrier. So if we provide smoke barrier separation, we have gone way over what was required for enclosure. And now we have provided the appropriate separation for those smoke compartments. Now, basically, the atrium volume becomes the very tall one-story space. Okay, well, that's pretty good, but we're going to take this to another level in a moment. So this satisfies the requirements for smoke compartments. We have not yet addressed the requirement for smoke control in this type of a lobby, but we'll look at that in a moment. And now let's look at something else that showed up in the 2021 code. So this was added as an exception for smoke control. So we know that we need smoke control in any atrium, but this gives you a way out of smoke control. Is this an off-ramp that we want to take? Well, this tells us that all stories above the lowest 2 stories have to be separated as if they were a shaft. Okay, what does that do? Let's think about this for a moment. So it says you can leave the bottom 2 floors open. We have done that. We've at least accommodated our requirements for enclosure by providing construction as required for a shaft above the 2nd floor. Now, first of all, construction required for a shaft is a fire barrier, so you're already right off the top limited to 25% of the wall as an opening. But if you read the information for a shaft, it will also tell you that you can't have any openings in that shaft wall that are not required for the function of that space. So if that space is functioning of a shaft, that window is accomplishing nothing. So it could very well, and according to the letter of the code, that could very well be non-permittable. So bear in mind why we're doing this. But at the end of the day, if this was permitted as we see it right now, what have we accomplished? We've gone through the trouble of taking away square footage that we might otherwise use and incorporating it into an atrium. And at the end of the day, we have more enclosure than we do atrium. So from the perspective of the fourth and third floors, we really don't get to experience that atrium as we would from the second floor or even from the first floor. So is this a viable solution? The answer is absolutely yes. Do we see this in the marketplace today? The answer is an emphatic no. We don't see it, probably because of the egregious nature of the non-open atrium as an end result. So let's go back to what we were looking at earlier with regard to separation. We noticed that when we have this separation show with just one floor, we have accommodated the requirement for enclosure, that being only one floor with sprinkler protected glass forming a smoke partition or a smoke partition. Now, what if we provide separation on the other floors? So what if we do this? Okay, well, we have complete smoke separation from floor to floor in accommodation with the requirement for smoke protection. So if you have this requirement for smoke control, there is no wording in the code that says it has to be mechanical. Why could it not be passive? If we provide these passive systems entirely separating each floor from each other floor, there is no possibility of smoke going floor to floor at all. The only thing we're solving for is smoke control in this case. So if we put smoke-rated fabric curtains on the floors to separate all of these floors from one another, we have satisfied the requirement for smoke control in this senior living facility. Now, this would work in a senior living facility if that senior living facility is condition 1. How might this look different if it was condition 2? Well, that separation would have to be a smoke barrier. And then you've separated 4 smoke compartments. You provided over and above what you need for enclosure, and you provided complete separation of all floors already. So that is your passive smoke control system. What if you have a corridor right there along that? So let's think about this for a second. What was unique about corridor construction in senior living facilities and I-1 occupancies? Well, they have to be constructed with fire partitions. Okay, so let's make those fire partitions. What else is interesting about that? Well, the fire partition provides separation from the atrium. So that separation from the atrium in this case can have openings in it for sure. And there's no limitation as to the size of the openings. So this is another great solution for fabric curtains. However, the fabric curtains also have to be tested to be fire rated to 20 minutes in addition to their smoke rating. So that's accomplished easily by smoke and fire rated curtains. So we could use those as openings on the right side or the atrium side of this corridor. What about 2-story openings? So we talked about vertical openings in general. We jumped right into atriums, but what if you have a 2-story opening? Remember, if you have a 2-story vertical opening in 2018 IBC, it can be an atrium. And your requirement for enclosure is nothing because 3 floors can be open. And your requirement for smoke control is nothing because there was an exception for smoke control in a 2-story atrium. But now the new definition that came in 2021 disallows a 2-story vertical opening to be called an atrium, except in I2 and I3 occupancies, which is not a senior living. So what do we have in the senior living facility that's 2-story vertical opening? Well, we have 2-story openings. Now we can't connect more than 2 stories. Okay, well, it's a 2-story opening. That's straightforward. And it can't be open to a corridor in a group I occupancy. Senior livings are group I occupancies. So let's see what we can do with this space now. So if we have a 2-story opening and we don't have it open to corridors, we can provide this solution. There is no requirement for separation if you have 2-story openings in a senior living and I1 condition 1 occupancy. Now you can see the complication if it becomes an I2, because right away we have to have smoke compartments. But let's put in a corridor. What if we have a corridor running along there? Same thing as before. We now have a 2-story opening, not an atrium, but we have a 2-story opening in which that corridor is open to that volume. What do we have to do with that? Corridors already in senior living facilities are required to be constructed with fire partitions. So we do that. Now we do not have that separation, or we have that separation between the corridor and this 2-story opening. Nowhere in the section for two-story openings does it say what that separation has to be. But we already know we have to have fire partition separation from the perspective of the corridor. So what about exit access stairways? Can we do that? Well, mostly exit access stairways are already in a predefined vertical opening, such as a two-story opening. You can visualize that in senior living, or in an atrium, and you can visualize that in senior living. But also, you have another opportunity here. If you have an exit access stairway within an opening or within a vertical opening that in plan is no greater than twice the size of the stair itself in plan, you can do that without separation of that exit access stairway. So you consider this an exit access stairway. It is not within a two-story opening. It is not within an atrium. It is just an unenclosed exit access stairway. Well, what are the requirements? Well, any slab penetration has to be protected with draft stopping. Draft stopping is defined as an 18-inch stop or a panel. Can be rigid. You almost always see this in like plexiglass in other facilities, but this can be deployable as well. And this is done frequently with fabric systems, deployable fabric systems. So you can do this provided the opening is no greater than twice the planned size of the stair.
This concludes our AIA Continuing Education On-Demand presentation. On behalf of SmokeGuard and the EBS Group, thank you for your time and attention. As a reminder, you'll need to complete a 10-question test to receive credit for this course. Simply click the test button below to get started. After completing and passing the test, you will receive your AIA Certificate of Completion by email to the address you provided before taking the test. If you're an AIA member and you provided your member number, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. To recap, SmokeGuard's core offerings include standard and custom elevator smoke containment solutions and vertical, horizontal, and perimeter fire and smoke curtains. If you would like information on any of our products, design support, or additional AIA presentations, you can contact our support team or visit our website. Additionally, the EBS Group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. SmokeGuard focuses on fire and smoke protection solutions, and Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on SmokeGuard, visit our website at www.smokeguard.com. Thank you again for your time and interest. We look forward to seeing you on our next AIA On Demand video presentation.